Next we will be discussing about Rolle's theorem and mean value theorem. First let us take up Rolle's theorem. If f of x is a real function and continuous in the closed interval a, b, f of x is differentiable in the open interval a, b, and if f of a is equal to f of b, then there exists a point C in AB such that f dash of C is equal to 0. Now there exists a point in AB means that there will be at least one point in the interval AB such that f dash of C will be equal to 0. Now these put together will be known as Rolle's theorem. Now let us discuss about the geometrical interpretation of Rolle's theorem. Now consider this graph of the function f of x. Suppose we have the function f of x like this. This is x minus x. This is y equal to f of x. So at these 2 points, say suppose this is a and b, and as we see from the graph, the function is continuous in AB. So there is a smooth curve and it is continuous in the closed interval a comma b, and it is also differentiable. Now what can you say about this point? This point is nothing but a comma f of a. What is this point? B comma f of b. Now it is very clear that the value of f of a is equal to value of f of b, which is nothing but the value at this point. Now look at this point. If I draw a tangent, now this tangent is going to be parallel to the x-axis. Now what is the slope of this tangent? It is nothing but f dash of x. Now if I take this point to be equal to c, then the slope of the tangent is nothing but f dash of c. Now since this tangent is parallel to the x-axis, f dash of c is equal to 0. So there exists a point c between a and b such that f dash of c equal to 0. Now this is the geometrical interpretation of Rolle's theorem. Now what if it has only one point, or it can be having more? Now suppose we have a graph like this. Now let us mark these 2 points as a comma b. This is a, this is b. Now it is so obvious that you can draw a tangent here which is parallel to the x-axis, a tangent here which is parallel to the x-axis, tangent here parallel to the x-axis. So we can find out many c's, c1, c2, c3, such that at all these points the tangent to the curve is going to be parallel to the x-axis. So it is not necessary that we can find only one point, we can find multiple points such that the tangent will be parallel to the x-axis. Now that is the geometrical interpretation of Rolle's theorem. Next we will see mean value theorem. Now suppose f of x is a real function and f of x is continuous in closed interval a comma b. F of x is differentiable in open interval a comma b, and there will exist a point c. There will be a c which belong to a comma b such that f dash of c will be equal to f of b minus f of a divided by b minus a. So this is the theoretical concept of mean value theorem. Let's also look into the geometrical interpretation of mean value theorem. Now consider this graph. So this is the graph of the function f of x. Now a and b are 2 points. As seen from the graph, it's going to be a continuous function. Now what is this point? This point is nothing but a comma f of a. And what is this point? This is b comma f of b. Now suppose I am locating a point C here such that this tangent at this point is going to be parallel to the line joining a comma f of a and b comma f of b. Now what is the slope of this line? It is f dash of x. So this point is C, as I told before. Now f dash of C is nothing but the slope of this tangent at the point C. Now we can see that this tangent is parallel to the line joining a comma f of a and b comma f of b, which is nothing but a secant to this curve. Now what is the slope of this line? It is f of b minus f of a divided by b minus a. Now since this line and this secant are going to be parallel, we know that their slope should be equal, which implies that f dash of c is f of b minus f of a divided by b minus a, and that gives geometrical meaning of mean value theorem. Now here we have a problem in Rolle's theorem where we have to verify Rolle's theorem for the function f of x is equal to x square plus 2x minus 8, where x belongs to the closed interval minus 4 comma 2. Now the very first thing is to examine the continuity of the function in the closed interval minus 4 comma 2. Now f of x is equal to x square plus 2x minus 8 is a polynomial function. Therefore f of x is continuous in minus 4 comma 2. Now what is f dash of x? It is 2x plus 2, which exists at all points in minus 4 comma 2, and thus f of x is differentiable in minus 4 comma 2. So we have to find the value of the functions at x is equal to minus 4 and 2, and we should check if they are equal so as to apply Rolle's theorem for the given function. Now what is f of minus 4? It is minus 4 the whole square plus 2 into minus 4 minus 8, which is 16 minus 8 minus 8, which is 0. Now what is f of 2? F of 2 is 2 square plus 2 into 2 minus 8, which is equal to 4 plus 4 minus 8, that's 0. Hence we have f of 2 is equal to f of minus 4. So we have all the three conditions satisfying Rolle's theorem. Hence Rolle's theorem is true for this function. Now we have to find the point C such that f dash of C equal to 0, isn't it? Now what is f dash of C? F dash of C is equal to 2C plus 2. Now f dash of C equal to 0, which implies 2C plus 2 is equal to 0, which implies C is equal to minus 1. Now it is true that this minus 1 is lying in the interval minus 4 comma 2. Thus from all the above steps, therefore Rolle's theorem is verified from 1, 2 and 3 above, and also by C is equal to minus 1, which belongs to minus 4 comma 2.